To have deep understanding into Spark, we need to have a high-level understanding on data frames, dataset, transformations, high-level and low-level API, lazy evaluation, partitions, actions, and RDD. I'm going to touch upon each of these particular topic in a high level so that we should be in a position to connect the dots, and when we are getting into the deeper discussion or a detailed discussion, it will help us to understand the concept and where it fits in a bigger picture. First, let us have an understanding on data frames. Data frames and datasets are the working horse of the Hadoop, where any data that is available in any source, either it could be data from RDBMS or a CSV or a tab separated file or a JSON file, JavaScript object notation, or a Parquet file, and there are n number of sources which produces data or which stores the data. This data can be read and it can be represented as a virtual table distributed across multiple systems, and the table will be represented as a virtual table which will have n number of rows and n number of columns. In short, data frame is nothing but data represented in rows and columns distributed across multiple systems, and it retains the data in memory. I can do any type of transformation on that particular data, like adding a row, removing a row, or working on any specific column, massaging the column, cleaning up the data. Any such activity I can do on that particular data frame. The internal building block of data frame is RDD, Resilient Distributed Dataset. That is the low-level API where we will be working at the dataset, and it has n number of low-level APIs. And data frame is made of n number of rows, and all rows will be untyped. Each and every row will be a generic row, and it will not be very specific to a schema. So I'll be having n number of rows and n number of columns, and each column will have same number of rows. In the sense, it will be very structured, and the data type is not typed, so we will not have a strong binding on the data type. Each row will be a generic type of a row class. Since it's a generic type of row class, any analytical error, it cannot be caught at the compile time. So the compiler will not know whether the operation I am doing on that particular data is valid or not. Only the syntactical error can be caught when we are working with a data frame. Let us see a small example how a data frame looks like. I have access to the Spark shell where I have installed Spark in this specific system. Let me open the Spark shell. The shell application will get opened in the local mode, so I'll be in a position to access the file available in the local file system. And as a part of the installation of Spark, there are some sample files. This is where I have installed the Spark, and there is a folder called examples that has n number of resources to try out various samples. Under examples, src main resources, where I have some sample CSV file, text file, JSON file, Avro, and Parquet. Let me open up a simple CSV file using the Spark. So within Spark shell, I have access to the Spark session. So I'll create a variable, and scalar is type inference. So automatically it will infer the type. So within Spark, I'll use a function read and open up the API. This is the API documentation of Spark in Scalar. I'm going to open the Spark session. So within Spark session, I should have a method read. So read will provide me a data frame reader. Say read dot option. So how I wanted to read this specific file? I want to infer the schema automatically. You can pass various parameters, and one more option. Say I do have a header, and I'm going to read a CSV file. So whenever I say read, it's going to give a data frame reader. So within data frame reader, I have a method called CSV. To read the CSV file, I can pass a number of parameters. We have passed two parameters. One is infer schema. Automatically it will infer the schema available within the data, and the other parameter we have passed is header. The default value is false. I'm passing it as true. And I'm going to read a CSV file available in this specific location. So the API will give me a data frame. The CSV will give me a data frame. I'm going to have a data frame, and each and every column, what was the header? So we had a header, name, age, and job, all of type string. Now I should be in a position to operate n number of methods within this particular data frame. So data frame has different methods. Data frame is of type, which is a generic data set where everything is of type row. People.count will get me how many rows I have within it. I can get the schema. So it has 3 columns, each of type string. So we have done the first demo where we have seen how a data frame exists. Data frame is nothing but a virtual entity where it can be available distributed across multiple systems provided we have a distributed cluster. Let me read another sample file where I am going to read a sample data which was created or downloaded from a website uci.edu. It was available as an XLS file. I have downloaded and made that as a CSV file. So this is where I have the CSV file. So this has a number of columns, and head will give information on. I have the header. I'm going to use this specific file to read using schema. The data from this particular location is downloaded. So we do have an XLS file. I downloaded, I opened in XLS and saved that as a CSV file. We will see example later how to read an XLS file as well later. So this is a quick introduction to get a feel on how a data frame looks like. I'm going to read this specific data, CSV data. I'm going to use the Spark session. I'll say read. I'll pass the options. It should infer the schema automatically, and it has the header. The location of the CSV file is this specific location. I'm going to explicitly say store this particular file in memory always. Now I can visualize this particular data frame as a table. Don't worry about the syntax in the introductory session. We are going to discuss all this, how to create a view, what is this table. We are going to discuss later. I can fire up a SQL query against this particular data set. So this particular data frame is having this specific schema: invoice number, stock code, description, quality, and I can get a number of elements within this data frame. It's going to get me 10 records within it. If you observe very carefully, each and every row is of type row. So it will not be in a position to know the type. That's why whenever we use a data frame, we call it as it has untyped row. I have registered this particular data frame as a view named retail sales. I can fire up a SQL query by picking the data available in that specific view. So what we have done, I have fired up a query, select description, the count of stock code as this specific alias name from this particular view where the unit price greater than 0, and I'm going to group by the description, and I'm going to order based on the item frequency, and I'm going to limit the output to 20 rows. This is very similar to what we write within a normal database, but it's going to act against the data frame which is available across n number of systems. So typically a data frame size could be anything. As long as we have a bigger cluster, we can have any size of data frame and we can do the analysis, and data frame has the capability to exist in memory. So we are going to get a very fast response whenever we do the query. So in short, data frame is nothing but any data available in any data source can be represented as a virtual table spread across n number of systems which has n number of rows and columns. Let us understand how data frame works within Python API. The logic and syntax all going to be the same. So let's try creating a sample data frame within Python world. I'm going to open the Python shell, the command pyspark. Since the bin folder of Spark installation is added into the path of my system, the commands available within the bin folder will get executed automatically. And this is the Python shell where we do have access to the Spark session here as well. I'm going to create a data frame by reading a text file available within the same location. So I'll be using the read method of Spark. I'll pass the option to infer the schema, and header, this text file is having a header within it, a data frame would get created. The schema of this particular data frame, you can get it. So what are all the columns and the types are available, I can verify. Let me register this particular data frame as a temporary view so that I can use it with the SQL queries. So I'm going to fire up a SQL query by getting the value on description and the count of the stock code, as well as I'm going to get the records where the unit price is greater than 0, and all the records would get grouped based on the description, and I'll get only the 20 records. So the result will get displayed. I do have the result. So behavior wise, DataFrames behaves the same, and almost many methods have the same syntax as we have within Scala.